Hello, I'm going to present our project video encoder. We have 4 members in our group. This is thus names. I will cover all these points, including organization, background knowledge, design, asymptotic analysis, data structure, compile instruction, minimize requirements, and stretch features. First, let's talk about organization. We have weekly meeting. Each week we would assign tasks to everyone, and mostly by the end of the week we would accomplish these tasks, and even if someone did not, we would all help him to finish his tasks. We have 2 sprints in our project. The first sprint is to build a prototype of this video encoder. We break into 2 groups in the sprint. The first group is the image group. It would be responsible for compressed images, and the second group would take images and render them to screens. After the first sprint, in the second sprint, we decided to fulfill all features, and in this sprint we do not break into 2 groups. Instead, we stay in one large group and each person work on one different aspect of this project. We have 3 video effects to work on, and also we work on the inner frame compression. The tools we used in this project, we use Google Group for context and notification. We use Google Doc to share references and notes so that everybody could be on the same page, and we use GitHub to host our project. The background of our project. First, we look into the ISO documentation of JPEG. We learned a lot from that, and then we learned the encoding and the decoding, the color space and transformation of JPEG, how to set compression ratio, and also we found a very useful interface, JPEG image encoder, to help us to do the things we need to for the images. For the video and GUI, we first found a very good references library, Mount Media. We learned a lot from this library, and then we decided to build our own video encoder. We look into MPEG, and then we decided it was a little bit too complex for this project, so we decided to use another way to play the video. We choose JFrame, and what we do to play video is to draw 24 or more images per second, so that what you saw on the screen would seems like a video. And the library we use for this project is all contained in JRE 7. Next, I will talk about the design of our project. As you can see, the video encoder class is the entrance of the whole project. From here, you can either use command line to go to the control part, or you can go to the GUI, and from GUI you can also use control pad to control the whole background process. And in compression, first we use this inner CMP classes to take images, and after this class it would produce the deleted frame images, and we would send this deleted frames images to image compressor class. This class would compress the images and then send the images to inner frame compare class. This class is contained in the video encoder, and it would add frames to the deleted frame images so that the images would seem perfect even after deleted frames and compression. And then after the video player, we render the video to screen. The asymptotic analysis of our project, as I have mentioned in the last slides, there are certain steps in our project. The first is 3 images. This takes n times. N is the number of images, and delete frames. This takes nm times. M is equals to a plus b. A plus b is the height and width of the images, which means n is the size of the images. Compress images takes nm times. Add frames also takes nm times. Calculate video effects takes n times. So overall, the whole process takes nm times. The data structure, we didn't use much complex data structure. The only two we used is array and array list. Okay, next I will talk about the compile instruction. First, you download our project from GitHub, and then you compile. One thing I need to mention is, because we use a JIE inner class image.codex.jpeg, so if you just compile in the usual way, like this, javac video encoder.java, it would say that they cannot find this package. So you need an extra parameter so that the system would find this references, found this library, and compile successfully. Okay, next I will talk about the minimum requirements of our project. The first requirement is to encode up to 100 images and encode them into one file. The file should be less than the individual file. So in the left, it is the size of the images, and in the right side is the encoded video file. As we can see, the video file is clearly much less than the images file. The second requirement is to play back images from the encoded file at least 10 images per second. So here, as you see, when you play the video, you can click the precise progress bar so that the video would go back to the previous point and play from that point. Next is provide a command line user interface of encoding and viewing. This is the command line interface. You can type in all these commands, and then the video encoder would run correctly. Okay, next is the stretch features of our project. We build a GUI for our project. This is the main menu. They have 3 buttons: the encode video, the play video, and help documentation. So if you click the encode video, it will go to video encoder, and from here you can choose image folder, choose destination video file, and then apply the instruction. This is the GUI of when you choose image folder. Next feature is real-time interesting video effects. We have 3 video effects. They are inverse, 2-grid, and multi-size. The multi-size sets the video played in its original size or default size. Basically, as different images have different sizes, so we can make sure. So we want to make sure that whatever the image size is, it would play in a default video player. So this is the default size of our video player, and whatever the size of images is, it would fit into this video player. But also, if you want to see the original size images, so you can click the original size, and you will go to the original size video player. Next function. The next feature is to gray. It will set color space from RGB to gray of each JPEG images by using this interface. So on the right it is the original video, on the right it's the grayed video. The third effect is inverse, and it would set RGB value of each pixel from X to 2.5 to X, and how you can see on the left it's the original video, and on the right it is the inverse video. Also, I want to mention that we set the gray and inverse independently. So when you are viewing the inverse video, you cannot see the gray video, and vice versa. But you can see the default size of or original size of different gray video or inverse video. The last feature is adjust parameter on movie. We set 4 parameter for our video encoder. So on the left it is the GUI of set parameter, and on the right it is the command line of set radio. So if you set different radios, the quality of the images and also the size of the video will differ. Thank you.